Go. Hello and welcome everyone to our show, Knowing Our Researchers as Celebrities. And today we have Dr. Yash Gupta, who is a research scientist in Mayo Clinic in USA. And we will be having this conversation for everyone who is interested in research and what they should know and what are the information which will help them to break their barriers which they are facing right now, because Empowering Science Foundation is a non-for-profit organization which believe in breaking the barriers, and that is the motto of ESF in all. And today, Dr. Yash Gupta will share us how so let's start with Dr. Yash Gupta's a very brief introduction. He is one of the scientists which you will find out that have almost published paper in everything, starting it from parasite biology in malaria to protein interactions, and now recently for the COVID also. So Dr. Yash Gupta, welcome, first of all, to ESFs.
Thank you, Dr. Kishwar, for having me here. I'm really honored to be interviewed by you.
Thank you. It's a pleasure of ESF. And let's start with how you started your journey and how you feel that breaking the barrier is important as a researcher.
Well, when you talk about the background education required, like essential education required for any researcher, so there is a huge gap. When you are doing, when you are pursuing a course, you are doing your bachelor's, master's, so you are given a huge syllabus and you are supposed to imbibe all that information and reproduce it successfully in that exam. So you are not being made a researcher at all. So being a researcher is asking a question. You have to question everything. And Indian education system, by its very core, is against asking questions. It's like whatever is given to you, just believe it like a faith and try to score high marks in exam. It's all about competitive exams, main subject exams. And I don't know if you remember how stressful it used to be just before a few days before exam. We used to like we are studying for 16 hours and just to prepare for that exam. And how much did we retain? We ask ourselves that how much of that subject matter I know now. I should say that I will be honest. I don't remember any of it. And and 90% of the course material didn't have any practical application for me in future when I pursued my career. And biggest part missing, I feel, was that there was no volunteering option. We have such a dense course material that it can never be completed. You realize in first semester or second semester, okay, this course cannot be completed. We have to just play the game and try to cover everything that might come in the exam. So these students, they are studying, climbing their mountain. They don't have any time, and that results in no time for volunteering. So the system, which is the parent system from which this is copied, they have 10% of the total course material. So what India has course material, they have a recommended reading. If a student wants to explore further or wants to go deeper, they can go for recommended reading, but that is part of the whole syllabus in India. So that massive course, and so the parent system, I'm talking about parent system, European countries, Germany, UK, USA. So these parent systems have 10% of the course. Rest is all in recommended reading. Read as you must, and there is volunteering options. From the first semester, kids actually do volunteer in the laboratories, in the field. They become teaching assistant. So you have to decide if you want to become a teacher or a professor, you become a teaching assistant from the beginning. You become a scribe. If you want to pursue a medical career or if you want to do a clinical research, you become a scribe. So basically you can do volunteer stuff. And then when you get a degree, you have 2 years of experience along with your degree. So that, and we complained, okay, we did our masters, but they need experience for giving us jobs. you could have got that experience if your course structure was lighter and you were exploring volunteering options. That is how it is supposed to be done. But now you have to waste another year to just gain experience, stick to somewhere and try to survive, become more like there is a complete gap. What you studied, you have to forget that. You have to learn new techniques. You have to understand biology in practical terms and learn how to write. That is the biggest thing. We are not taught to how to write original research work. So you have to learn all that. And then you become a researcher. So this huge gap between education and research is you have to break that barrier. Okay. It's like you are trapped inside water which has an ice sheet on it. You cannot come out unless somebody gives you a hand. And I was lucky to have those hands in my life. I got such teachers who just pulled me by my hair. So few left, but I had those guys. I was lucky, and I have seen brilliant minds, and very enthusiastic and sincere and real scientific students with scientific aptitude. They lost interest in science. They could not convert their education into a successful research career.
So here, if essentially what I understood is the role of mentor is very important if you want to be a researcher. Then how would you like to share your experience of your first mentor, or as you said that you got those hands which took you out, and how was that journey from there on?
So the first hand was Dr. Chincholikar. He was a chemist when I was doing my bachelor's. So when I was doing my bachelor's, I had no interest in science at all. I was just preparing for my medical entrance. That is a thing in India, that you prepare for medical entrance. And I didn't want to have a gap year in my studies. So I did a bachelor's. And he was my professor there. And I never used to pay attention in his class, and I didn't care what was going on. But when the practicals start and you see different colors and you basically you do wizardry stuff, like you mix this and this happens. There were blasts, flames. I loved it. This is like first time I could do something with my hand, which I used to do and get scolded at home. So it was the best part of that education, that, okay, there is a practical aspect to it and it's fun. And Dr. Chincholikar made it fun. He told me that, okay, this is the atom that will do it. And that visualization of what we are reading into practical context, that was the first part I got. And then I started understanding that, okay, practical is slightly different. What you read, you have to imagine how it will be done practically. And then during my master's, I had a close relationship with Dr. G.B.K. Prasad, and he was real good mentor. We used to not understand his course structure. He didn't care about syllabus. He didn't care about anything. If he was teaching about, he used to teach us immunology. So if he was talking about clonal selection, he will go to the end of that subject and he will forget what syllabus was. And we would say that what will come in exam. He will just laugh and leave. So, but that came in very handy when I started being a researcher. So that attitude that you don't care what the basic information is, you have to question everything. Even if there is a paper which is in Nature and it is published in last year, you have to question it. What method did they do? And can I do a better method? If I change this method, is it, so basically when you have a method, you have a procedure, you have a hypothesis. So basically you are trying to solve that in a given framework. So that answer might not be valid in a different framework. So that universality you have to test. You have to question everything whenever, even if there is a difficult paper and they have tried to answer a very complex question in their way. So you have to think that, okay, if I change this way, will this answer be universal? And in the clinical setting, will this answer be universal? So that question is what research is. You cannot educate and you cannot just mug up and just know the history of what year some invention was done and become a good researcher. You have to have a journalist and you have to have a prankster to design experiments, and you have to see, yeah, let's see if there's nothing happening. There will be some nice colors or fun attached to it. So I felt that these people actually shaped my mind a lot. And when I did my PhD, so my PhD supervisor, Dr. Kiran Koto, she was so busy. She was a full-on clinician. She used to have a clinic duty for 8 hours. So I could not ask much time from her to mentor me or anything. So I turned to my seniors for help and design experiments according to new papers. I learned a lot. So that learning curve was shortened for me because I was like, basically I was kicked out of the nest. So this experience actually helped me a lot. So when I see a lot of people, they rely on their PIs or mentors to design their experiments, suggest what should we do. We should take their advice. They are more experienced than us. But we should not lack initiative from our side. That is the most important part. Once you lack initiative from your side, then you are not being a researcher. Whatever you are not a researcher. So that demarcation has to be there. There has to be a flavor from your side. There has to be a main driving force, conviction on your side that this hypothesis, I have to do these things, but if I don't understand a certain aspect of it, I will seek help.
So how I see this as like what you are essentially saying is that you have to have a concept, basic understanding of it, and then you have to have this enthusiasm that you should bring your own questions and you should have the power to question anything and everything. And then you seek for the solutions for that question. How about if a person who is, as you correctly said, that simply just following the education system, what we have, where we don't have practical opportunities to do anything and to explore, then if a person have a question in India, and when these budding brains are having the questions either in their BSc or in the school, what do you suggest them, how they should look for the solutions, or how they should know that if there is a spark in there and what they can do about it?
Well, while my complaints with education system is more at policy level now, I really feel that we are failing those students by making science uninteresting and a burden. If you are enthusiastic, yeah, I want to pursue science. That's the student who is taking entrance to your course, and by the end of the course, 90% of them say, yeah, science is not for me. Then you have failed as a course material. You are not educating them. You are discouraging them to become real scientists. So that is my actual, but still within the system, because I survived that system. So what I can say is, you have to maintain your enthusiasm. You have to maintain your curiosity, and that child inside you that, okay, yeah, whatever you're saying. And so there is a Greek philosopher's quotation, and I have forgotten his name. God forgive me. So that's the motto I follow. That I forget this. The subject matter is the important thing. So if you can vein, like if you can compare anything without believing in it from the beginning. If you have two questions, okay, this might be happening. Earth could be flat. Earth could be round, and without believing that, if I believe from the beginning that, okay, Earth is round, I know that. I have been taught that. I know that Earth is round. And I don't care what they have to say. Then you are wrong. You have, for an educated mind, you cannot have a bias. You have to entertain the question, oh, Earth is flat. Okay, how do you come to that conclusion? Let's see, that's interesting. If a human being has made some experiments and learned Earth is flat, then I want to know about it. So that's the attitude you have to have. Both the notions, both the sides of the coin, you have to have a curious mind. You have to entertain that thought without believing in it. So that is association. Because I'm studying something, Earth is flat or not, I cannot believe that, okay, I believe it is round. I'm going to do all these experiments, but I believe it is round. That personal biasness and personal prejudice we have to be very careful of. You have to believe nothing. Whatever, you have to believe in what you did as a solid experiment and what results you got, and what is the significant correlation or association, what statistically your story is telling you without doing sampling bias or any other kind of researcher based bias. Because a lot of Indian research, when we see even old people who didn't get a lot of international exposure, they do that. They actually have premonitions. Okay, this should be happening, and they try to prove that. They spend their whole life proving that. But a real researcher is if you can entertain a thought without being biased, even if you don't believe in it. But if you don't believe in it, design experiments that can do that differentiation. You should be able to make a demarcated difference that, okay, I have certain idea how we can for sure that Earth is round or flat.
Nice.
Once you say that I will prove how Earth is flat or I will prove how Earth is round, then you are not doing science.
Okay. So essentially, when you are doing a hypothesis, how important, because what I am understanding from your thing is like you should not be biased while designing a hypothesis, which you are going to perform experiments and want to prove in some time. Keeping this aside for now, for a while, how, like when we talk to Dr. Yash, how he has traveled this journey, how he got interested into research, and then over more than the experience of almost 2 decades. Would you like to share some of the insights of your research and like, because this is for general community, so we can keep it simple, because you are talking about data, you are talking about, biases and so many things.
I'm talking about the philosophy behind research. I am talking about prejudice. I'm talking about like premonitions, like people believe in their dreams, they should believe in their dreams. But when you're designing experiments, you cannot be biased. You have to, so being educated, that's the Greek. So we say that all the democracy and all the great thoughts came from Greek philosophers. So they have this saying that if you are educated, that means you can entertain a thought without believing in it. So that's the problem of this world, that when you say somebody is intolerant or ignorant, they are not ready to even hear the notion just because they don't believe it from the beginning. One should bear that refusal to get to the logic. Logic is the God. It's not your feelings or your prejudice. That's what I'm saying, and it has, I think, universal applicability. And people actually form opinions just based on what they think or what unrelated experience of past, and that creates a prejudice. That creates intolerant mindset that, okay, I don't want to hear what other person has to say because that idea doesn't fit well with my narrative in my brain. So that is the thing which is true in every, I think, day-to-day life even. So that's what I'm trying to say. Sorry for going so technical on you.
No, so how about like when you have started your research career of almost more than 2 decades now, how you see that you have you started with a hypothesis, and then you might have done research in more than 2 or 3 fields, which I am aware of, and how it is important to keep these things going in a way, like you chose those moves, or you believe that it was the question behind your like the question which you started from field A, then you thought like, no, I might explore this further, and that's the reason why I can do something else, or you believe that just because you know something now you can do everything. How does that work in research?
So basically in research, what you do as a primary, what I understand from your question is that you are talking about what is your primary foundation of building up a research career. So primary foundation is hard work with practical skills. You have to understand aseptic technique. You have to understand basic molecular biology, basic proteomics, basic understanding of how a lab is arranged and how records are kept and how documentation is important. And that is the information, again, that is missing from all the coursework. And how do you communicate your research? How you write that down? How you apply for funding? So all that information is not taught in our coursework, which is 90% of our career, which is the major part. What we are taught is only 10%. When we are forming a hypothesis, then we think about what has been done. And again, that is not, we didn't dig, we just don't meditate and dig in our coursework, which we studied long back. We have to look at new papers. We have to update ourselves with new research. Again, that is not taught in regular coursework. So a proper research training is the foundation. You have to join a lab. You have to work like, you have to go out of your comfort zone. You have to learn all these things by taking part in small conferences, whichever conference you can find. You have to learn to face peer review. You have to have confidence in what you're doing and try to defend it in a scientific forum when you're questioned and they have a cross-questioning. So you should be sound with your logic and your hypothesis and what you're doing. So basically, actual science as a researcher is having multi-components, and that can only be done if you initially join a very vibrant and productive lab, and basically you learn everything what they're doing. You should have, you should not be like, okay, I am getting my salary, I'm getting my hours in, I'm doing this, I'm doing that, and I will get Nobel Prize. So apart from all that, it's all important, but main target should be that to learn all that part. You have to be proficient in doing all that. You have to know how to work with co-workers. You don't want to ruin anybody else's experiment. You don't want them to ruin your experiment. You have to have that defined work ethic, and all that thing only happens when you start standing on the bench. So leave your computer, start working on the bench. In a couple of years, then you can start doing your own research. That is a major fraction of it.
So how about, because what I understood is like it's a lot of work, what I can hear, either it is in lab or on computer or thing. So how do you maintain the work-life balance? Because that is one of the things which is giving stress among all the researchers, and some of them are quitting the field because they are unable to maintain the work-life balance. What are your thoughts about that?
That is a universal thing. It's not just research, and you have to decide what you're going to do with your free time. If you have incubation for 2 hours, you can read more about that experiment. You can see frequently asked questions. You can look at the troubleshooting things. So basically, when you are a researcher, you are told about multitasking. You cannot do same thing every day. That is the beauty of the research, that what you do today, you might not even do for 3 or 4 months. So research is it teaches you to be multitasking. So I have seen researchers to be very good with maintaining family work balance, because you can switch off. There is no continuous process going on in your brain. Okay, now I'm home. And even if I'm planning to do some writing in my home, I can take out 1 hour in the late evenings and do that. So I don't have to make my family life suffer, and weekends are for my family. So researchers have that independence once they have things in their hand. Initially, in the learning phase, you have to put in hard work as much as possible. For good thing is that at that time, you don't usually have a family. So enter into family life only when you're like through that. You are good at your work, you are independent, then start a family. That's how it's in every career. And researchers are very good at maintaining their families because they are taught to be multitasking.
Yeah. That is so positive. Not many people share the same thing, but we are glad that we have. And this is the note for audience that it is up to you, as Dr. Yash said, that you decide your own boundaries. And in research, you have plenty of time to make a work-life balance. So as what I understood is like family is very important, and you do give all the due credits to family. How about your family background? From what background you come, and how that background has helped you to be a researcher?
So my father and my mother both are lawyers. So there is no understanding of science back at home. So and my father is in judicial services, was in judicial services. So uh, it has nothing to do with what I'm doing. But what my parents did from the beginning was let me decide what to do. I was never told that, okay, you have to become this, you have to. I just did whatever I wanted. And that's what led me here. So I am angry and grateful at the same time. So if something bad happens, I blame them. And I'm very grateful, all in all, for all the independence I had and all the fun I had with science. And yeah, and my brother is super supportive. He's an engineer, and still he calls me crazy scientist in every conversation. So yeah, it's fun, and that's the thing. So I, when we get back to your question, that work-life balance. So thing is that uh, there is a big component in research that it is frustrating. So when you are trying to do an experiment, sometimes they don't work, or they don't work due to some technicalities. Sometimes they simply don't work because what you thought, what your hypothesis was standing on, could not be. There was some gap, and then that's immense pressure on you because you have to redo a lot of things. So research sometimes can be really frustrating and unrewarding. So when that happens, you become bitter and you take it out on your family because that's your comfort zone. But I have I never did that because my parents never did that. They had problems of their own in their work life, and they never brought it home. So that is a training. That is a training I got from my parents. That okay, you don't bring your baggage from your workplace to your home. And I have a tendency because even if my research is going negative, I think I need more entertainment to get away from it. So my philosophy is that I actually actively do balancing. That okay, I'm feeling depressed, I need to go out, I need to take pictures of birds or something like that. So that's part of it, and you have to have outlets. You
Mhm.
cannot bottle everything in. You have to have outlets, you have to have ways, you have to have friends. You have to like, okay, it's not working, I need to sit around and talk to my friends and go out and have some nature thing. I have to have an outlet. Otherwise, if you bottle that in, you will poison everything around you.
So I think if we are in the last few minutes of this conversation, and what I understood from Dr. Yash Gupta for all the researchers, that you have to have some outlets, you have to have decide that you have to have somebody's back, either it be friends, families, or where you can just go and relax, feel relaxed when your experiments are not working, and you do need them when they are working so that you can celebrate it with them. So you need this background. So last few words, Dr. Yash, what you will suggest a researcher who is facing some problem, or a person, a student who wants to pursue research as a career. How, like, what are the your experiences which you want to share with them? That what is the most important thing?
Most important thing is you have to stress very strongly on take home messages. By the end of the day, what you took home, what did you learn from all that experience? If you were made to reply to your boss's email, or you were given a thesis to review for somebody else, uh, what did you take? You learn because you are going to do that in the future. That is what your career is going to evolve. So it's easy to complain, and you have to learn to say no. Of course, if you are getting like 10 of those, okay, every thesis will go to this guy to review, then it is wrong. That's not your job. They cannot make you do their job. But there is a certain level that, okay, that is a learning experience for me. I should try to jump in and give my best and try to see if I can get off my training wheels. And you have to push your comfort zone. You have to do that. But you have to learn to say no, that, okay, access is not, I have done enough. This is the learning experience. This is exploitation. So research, you have to understand whatever you're doing, is it going to help you in long term? In 5 years, are you going to do that same thing? Yes, you are going to review thesis, you are going to review papers, and you are going to answer a ton of emails of yours. But that experience will count. But you have to understand what is learning and where to say no, what is good for you. And that is a constant monitoring on yourself. And there was a big phase in my life when I didn't know how to say no. And that's when things get ugly. So you have to put down your foot, like, okay, this is my limit. I can help you. It's good for me also. I will learn something out of it. But beyond this, this is not my job. It's your job. Don't pile everything on me. So it's all about balance, as you said. It's all about balance, and that comes with experience. So instead of complaining from the beginning, and because our education makes it so different, like what you are educated is totally different from what you're going to do. That's beauty of science. So you get very complaining in the beginning, like, oh, I don't know, is there a book with all those protocols? Where do I find how to make an SDS page? So, and why it's not working, why my gel is not gelling. Even I followed everything in that happens. So you have to spend a lot of time in the bench, and you have to learn the basic skill, which might not be taught anywhere. And basically, how SDS page is gelled, it's not even biology, it's chemistry. So you don't even have to understand that. You have to do it. You have to learn it. So there are certain aesthetics in every career, and you have to try to add as many as possible. But you have to learn to say no, but not no in the beginning. Then you learn nothing. So you have to understand what is moderation, what is the learning experience, what is exploitation, and set your limits. When you have, like, okay, then when things become routine and you're not learning anything, you're just doing things in routine, just stop doing them. They are not good for you. You know what to do, and you can try your energy. You can spend your energy in something more in agreement with your future plans.
Well said, Dr. Yash. So I believe that our audience will take the wisdom of Dr. Yash to their labs, to their lives. And as Dr. Yash said one thing, and I know him as a researcher, I know him as a person. So he just said one thing, that he responds to all the emails. And you can Google Dr. Yash. You can write your questions if you have personal. And he just said that he do respond to that. And if you want to connect with ESF, you are more than welcome. And we can get you connected to Dr. Yash Gupta. This is our episode for today, and we'll be coming with more. Thank you, everyone. And thanks a lot, Dr. Yash, for spending time with us. And I'm sure that you will be getting a tons of emails from young researchers. Some of them might make you feel happy, and some of them, who knows what it's going to be. Thank you very, very much, and have a great time.
Thank you so much for having me. It was a very fun experience. Thank you.